AC is the diameter of a semicircle shown. AB is equal to 8 centimeters, BC is equal to 6 centimeters, and angle ABC is equal to 90 degrees. Calculate using pi as 3.142 where necessary, the length of the diameter AC. And so here we have the diameter AC, and if you notice that this diameter AC is one of the three sides of this right angle triangle. And so let's label this right angle triangle. This right here, AC, is the side that is opposite, the right angle. And so we call this C. And again, we do not know what this side is. And so we put a question mark because we don't know the length of it. Let's call this side A. So we call this an A. And we're going to call this one a B. All right. So 6 is B. All right. And so with this label like this, we can use the Pythagoras theorem. And the Pythagoras theorem states that C squared is equal to A squared plus B squared, where C is the hypotenuse or the longest side, and A and B are the other side lengths of the right angle triangle. Here, A is 8 centimeters, right? B is 6 centimeters. So we have 8 squared, which is 64, and we have 6 squared, which is 36. And so we have C squared is equal to 64 plus 36, and 64 plus 36 is 100. So we have C squared is equal to 100. Next, we are going to take the square root of both sides, and then we cancel this with this. So we get that C is equal to the square root of 100. Now, what is the square root of 100? Well, the square root of 100 is 10, so C is equal to 10. So that means that AC, this length AC, is 10 centimeters, and that's what we have here. AC is going to be equal to 10 centimeters. That's the length of the diameter. Next, our goal is to determine the area of the triangle ABC. Now, the area of the triangle is going to be given by the formula base times height over 2. So the formula that can help us to figure out the area of the triangle is base times height divided by 2. Here, the base, right? The base is 6 centimeters and the height is 8 centimeters. So the base is 6 centimeters, right? And the height is 8 centimeters. So that's going to be 6 centimeters times 8 centimeters, which is going to be 48 centimeters squared divided by 2, which gives us 24 centimeters squared. So again, 6 centimeters times 8 centimeters gives us 48 centimeters squared. We divide that by 2 and we get 24 centimeters squared. And so that is the area of triangle ABC. Next, we need to figure out the area of the semicircle. Now, what is the area of a semicircle? That's going to be pi r squared all over 2 because that's the area of a semicircle. That's half of a circle. So that's going to be, take the area of a circle, which is pi r squared, and divide it by 2. And that's how you get the area of a semicircle. Now, what is pi? Pi is 3.142. What is r? R is half of the diameter. The diameter is 10, that's AC. We divide by 2, we get 5. So the radius is 5, right? So we have 3.142 multiplied by 5 squared, right? Now, all over 2, all right? So what is 5 squared? 5 squared is 25. So we have 3.142 multiplied by 25 all over 2. When we multiply the numerator, we get 78.55. So 3.142 multiplied by 25 is 78.55. We put it over 2. We divide it. And when we divide it, we get 39.275 centimeters squared. So the area of the semicircle is 39.275 centimeters squared. Next, we have to figure out the area of the shaded region. Now, the way that we're going to figure out the area of the shaded region is we're going to take the area of our complete semicircle, and we take the area of the triangle and we subtract them, all right? And so that's how we're going to get the area of the shaded region. So we have the area of the semicircle minus the area of the triangle. The area of the semicircle is 39.275 centimeters squared, and the area of the triangle is going to be 24 centimeters squared. We subtract and we get 15.275 centimeters squared. So that means that the area of the shaded region is 15.275 centimeters squared. And that's the answer to this question.